Good evening, teacher, and thank you for taking your time for this presentation. And today, my team is responsible for presentation about this whole chapter, which is 3G technology. So let's get started. So here are all of the content that we are going to cover today. So the first one is basic of 3G transmission network planning. Before we get into the main point of this heading, I need to explain you about what is the scope of transmission network planning. The scope of transmission network planning includes the region constituting for the interface between the base station and remote network control, and between the remote network control and the core network, and between the remote network control and the remote control itself. Moving on to the next slide, which is base station. In 3G transmission network, base stations have a very important role that differs significantly from their role in GSM transmission network. About the GSM transmission network is the global system for mobile transmission networking. In GSM network, the calculate capacity was based on knowing the number of transceiver, but in 3G, the emergence of the data have the alter the component of the base station, leading to change in the network dimensioning and operation. So moving on to the next slide. The next slide is about the antenna, filter, and the power amplifier. The function of the filter is to separate the transmit and the receive signal, while the amplifier purpose is to increase the strength of the received signal. And about the transceiver, a transceiver is composed of a single transmitter and two receiver, with the two frequency bands separated by 190 MHz. The most different of the GSM transceiver are precise power control, a unique frame structure, and a distinct channelization. For summing and multiplexing unit, the summing and multiplexing unit combine the signal from other summing and multiplexing unit or another signal processing unit. If you take a look at the picture, you can see that here is the combine of signal that it gets from another processing unit. It is just a sample picture for it easier to understand. Okay, so moving on to signal processor. The major function of this unit is to perform coding, decoding, and code channel processing, both in receive and transmit direction. For the application manager, it is responsible for several crucial functions such as operation and management function, carrier control, and more. It holds a similar role in transmission network planning as transceiver in global system for mobile transmission network planning. However, the number of application manager required to solely dependent on the traffic carried by the base station and is not related to the number of cell or transceiver. For the ATM cross-connect, the abbreviation for this is AXC. The AXC unit is accountable for cross-connection at the ATM level and serves as the interface between the application management and the interface unit. The AXC unit can be implemented as a standalone unit. For the switching unit, ATM is the fundamental technology that forms the backbone of 3G network. In radio network controller ONC, the switching unit is responsible for providing the necessary support for ATM traffic. The switching unit conducts various tasks such as ATM cell switching, AAL2 switching, and the traffic multiplexing. It is crucial to have robust and efficient switching unit to ensure a seamless transfer of the data in the network. Okay, so getting to the next slide. The next slide is about the radio network control, which is ONC. The radio network control ONC in 3G network is equivalent to the base station controller, which is BSC, of the radio network. While the remote network controller and the base station controller share similar function, the ONC has an additional interface which connects to radio network controllers. For 1.10 is about the control unit. The radio resource management, which is called RRM, is widely regarded as the most crucial function of the remote network controller, as it affects all three network planning entities such as radio, transmission, and core. The control unit of the ONC play a significant role in ORM functions such as handover, admission control, power control, and load control. It also manages control mechanism for package scheduling and location-based service. So here is another big heading for this chapter, which is transmission network planning process. The transmission planning process in 3G network is fundamental, similar to the global system mobile transmission network, with one significant addition, the inclusion of ATM technology. The process includes nominal planning, the detail planning, with dimensioning being a crucial aspect of the nominal planning, and parameter planning for ATM being a major change in detail planning compared to the GSM network. While the planning process for most areas in 3G network is quite similar to that the GSM network, and the ATM technology is a key component that impacts transmission planning. In this next slide, we're going to talk about the nominal planning. The nominal planning in 3G network follow a similar process to that of GSM transmission planning, include aspects such as protecting link budget, calculation, topology, and equipment dimensioning. However, the key difference lies in the dimensioning of the transmission network, which become more complex and critical due to the presence of the voice circuit switch data, packet switch data. This include both real-time and non-real-time traffic, further complicating and the dimensioning process. So here's the asynchronous transfer mode, which the abbreviation for this is ATM. The asynchronous transfer mode ATM is a switching and a multiplexing unit used in broadband integrated service digital network, which is called BSIDN. The BSIDN is a network that supports digital connection with rate greater than the primary rate for various services, including voice, data, and multimedia application. The ATM technique uses a small packet called cell to transfer information. Each ATM cell is 53 byte long and consists of 5 byte header and a 48 byte payload. The cells are multiplexed to form virtual channels, which are then multiplexed to a form virtual path for the transmission over the different media. So, moreover, here is the cell structure. The ATM cell structure depends on the type of interface used. There are two types of interface: user to network interface, which is we call UNI, and the network to network interface, which is NNI. The UNI is the interface between the ATM terminal and the ATM switch, while the NNI is the interface between two ATM switches. Okay, so go to another slide. The another slide, we're going to talk about the header error control. The header error control, or we call HEC, is an important part of the ATM cell header. So we need to pay more attention about this part because the header error control serves the purpose of detecting and correcting 1-bit errors in the header. The header error control is an 8-bit field that is calculated and set at the transmission side and is used to detect errors at the receiving side. So we are going to talk about the payload type. The payload type in ATM cell indicates the type of the information that the cell is carrying. There are two main types in the information: the user information and the management information. The user information is the actual data being transmitted, such as voice, video, or data. The management information is used for control purposes within the network, such as signaling or resource management. Another one is the cell loss priority. The cell loss priority stands for CLP. It's a 1-bit field that indicate the priority for a cell loss. It is used for traffic management in the ATM network. There are two priority for ATM cell loss, X1 and 2. I think this is a binary number. When a cell is marked with CLP equal to 1, it means that it has a higher priority for cell loss than the cell marked with CLP equal to 0. During the period of congestion in the network, cells with CLP equal to 1 are discarded, while before cells with CLP equal to 0. We're going so far, and now we reach the 3.5 type of layers. Okay. There are three types of layer, which is the ATM protocol layer. The ATM protocol layer are based on BISDN protocol reference model, which include the three plane user control and management. The user plane handle user-related information such as flow control, while the control plane handle control-related information such as call control. And for number 2, physical layer. In the ATM protocol structure, the physical layer has two sublayers, the physical medium and the transmission conversion. The physical medium is responsible for a bit arrangement, line coding, and electrical or optical conversion. The transmission conversion, which is above the physical medium layer, is responsible for maintaining the ATM cell rate by adding or extracting cells as a function of the transmission conversion layer, includes cell delineation, frame generation, and the frame recovery. Okay, so for the third layer, the physical layer below it, the ATM layer is responsible for generic flow control only for UNI and generating and extracting cell header. This layer also performs VPI, VCI translation and the switching cross-connect log and the multiplex cell from the individual VP and VC into composed cell stream. So we're going to talk about the ATM adaptation layer. There are four types of the layer, which is AAL1, AAL2, AAL3 and 4, and AAL5. The AAL1 is responsible for use for constant bitrate traffic such as voice and aim to minimize delay by keeping overhead to a medium. The AAL2 designed for variable bitrate traffic such as compressed video and video binwidth efficient transmission for short variable length package. Can also do an error checking and sequencing of data. AAL3 and 4 used for data transfer function and allow the effective usage of the virtual channel in the applications such as X25. And the last adaptation layer, which is AAL5, AAL5 is similar to AAL34 but more efficient and can be used for both message and stream mode of the data transfer. So here's the main part. So here's the final part that I'm going to cover, which is the multiplexing and the switching in the ATM. VPI or VCI value may change as the cell traverse through the network. With local significance only to each interface, cell can be switched on either the VC or VP level, depending on the level of switching performance at this cell. If a cell is switched on the VC level, it is switched from one VP to another. While switching on the VP level include all VC in the particular VPs through the transmission path. So here all I'm gonna pass this presentation to another presenter.
Respected teacher, my name is Lai Jin San and I'm going to represent my part, which is dimensioning. What is dimensioning? Dimensioning determines the capacity required to meet traffic demand in a telecommunications network. It's crucial to ensure efficient and effective network operation without congestion or service degradation. (4.1) VAF. So VAF or volume adjusting factor is a measure of the variability of traffic volume in a telecommunications network. It is used to adjust the capacity required in the network to account for variation in traffic volume. VAF is calculated as the standard deviation of the hourly traffic volume divided by the average hourly traffic volume. So for example, if the average hourly traffic volume is 500 lang and the standard deviation of the hourly traffic volume is 100 lang, then the VAF is 0.2. So it's come to that a higher VAF indicates a higher degree of variability in traffic volume, which requires a higher capacity in the network. So in 4.2, SHO. SHO, or sharing ratio, is a measure of the degree of traffic sharing among network elements. It is used to determine the capacity required in a network to accommodate traffic demand that is distributed among multiple network elements. SHO is calculated as the total traffic demand divided by the sum of the capacity of the network elements. For example, if the total traffic demand is 500 langs and the sum of the capacity of the network elements is 600 lang, then the SHO is 0.83. So it's come to that a higher SHO indicates a higher degree of traffic sharing among network elements, which requires a lower capacity in the network. 4.2, protocol overhead. Protocol overhead is the amount of additional data that is required to transmit a unit of user data due to the use of communication protocol. It includes header, trailers, and other control information that are added to user data to facilitate its transmission protocol overhead. Protocol overhead is significant in dimensioning because it affects the capacity required in the network. It is calculated as the ratio of the total amount of data transmitted to the amount of user data transmitted. So for example, if the total amount of data transmitted is 800 bit and the amount of user data transmitted is 500 bits, then the protocol overhead is 1.6. A higher protocol overhead indicates a higher capacity required in the network. So 4.4, signal overhead. So signal overhead is also the amount of additional data that is required to support signaling messages in a telecom network. It includes the overhead associated with call setup and call release and other signaling function. Signaling overhead is significant in dimensioning because it affects the capacity required in the network. It is calculated as the ratio of the total amount of signaling data transmitted to the amount of user data transmitted. For example, if the total amount of signaling data transmitted is 200 bits and the amount of user data transmitted is 500 bits, then the signaling overhead is 0.4. So it's come to that a higher signaling overhead indicates a higher capacity required in the network. So lastly, 4.5, signaling on transmission interfaces. Signaling on transmission interfaces refers to the use of signaling protocol on transmission links between network elements. It is significant in dimensioning because it affects the capacity required in the network. And the signaling on transmission interfaces is calculated as the ratio of the signaling data transmitted on transmission links to the total signaling data transmitted in the network. So for example, if the signaling data transmitted on transmission link is 100 bits and the total signaling data transmitted in the network is 500 bits, then the signaling is on. So last but not least, other factor. So there are several other factors that need to be considered in 3G network dimensioning, such as traffic intensity and blocking probability. Traffic intensity is calculated as the ratio of the total traffic demand to the number of network elements, And blocking probability refers to the probability of a call being blocked due to network congestion. And efficient planning of these factors ensures that the network can handle the traffic load without congestion or service degradation. So here we come to part 5, which is microwave link planning. So microwave link planning is a way of making sure that the signal sent between different parts of a 3G network using microwave technology work properly. So in microwave link planning, we have GSM transmission for a blur of 10 to -3 is considered good enough for voice traffic. And also with more data traffic, a blur threshold of 10 to -6 is considered during link planning. And the standard such as ITU TG.828 and ITU TI 356 and ITU TI.357 are recommended to be used in microwave link planning for ADM-based networks. And its recommended threshold while used for PDH and SDH are 10 to -3 and 10 to -6 respectively. And ADM performance is measured using parameters such as the cell loss ratio or CLR, which needs to be kept to be a minimum. And the availability targets are usually kept larger than 99.99, but may vary based on operators' requirements. In 5.1, topology in transmission networks. So how is it important? So transmission networks are important for mobile phone to work, and in the past these networks used different shapes like stars, chains, and loops to work. But in newer networks like 3G, they prefer to use a star shape. So the reason for this is because of two important things: the amount of stuff people use their phones and the time it takes for things to go through the network. And in 3G network, people use voice calls, message, and their things on their phones. If a lot of people are using their phones at the same time, it can cause a problem for a network. So they use a star shape to help make sure everything works properly. Also, when people use their phone, they don't want to wait a long time for things to work. If the network uses a chain or loop shape, it might take too long for things to go through the network. So using a star shape helps make sure that things work faster. Here we come into part 6, which is detailed planning. So detailed planning has 4 major aspects, which is 2 megabit planning, parameter planning or ADM, synchronization, and network management system or NMS planning. And when it comes to 2 megabit planning and NMS planning, there are certain principles that need to be followed here. And on part 6.1, parameter planning. So parameter planning is crucial in transmission network planning because of the involvement of ATM, which is also called asynchronous transfer mode. This has made transmission planning in 3G network more complex compared to GSM networks. There are 2 main aspects of parameter planning in ATM networks, or configuration parameters and performance related to parameters. Before dividing into parameter planning for ATM services, it's important to understand traffic management on the ATM networks. So, 6.2, traffic management on the ATM. ATM network have permanent virtual connections, which is called PVCs, and a switched virtual connections, SVCs. So PVCs are set up permanently by NMS or element managers, while SBCs require signaling protocol, which is UNI and NI to set up the connection. And signaling in ATM is always considered outband and has dedicated VCI and BPI values. So to set up a connection on ATM device, so one ATM device send a signaling request to the connected ATM switch with the destination point address and QoS parameter. And the switch examine the signaling packet and set up a VC on the input link, forwarding the request to the next ATM switch until it reaches the destination. And if the switch cannot provide a desired QoS, the request is rejected and a message is sent back to the origin point. So upon acceptance of the connection, traffic management function ensure that each of the connections adheres to the traffic contract as agreed. And lastly, traffic management function and techniques include traffic parameters, connection administration control CAC or conformance monitoring and control, and also queuing. Six point three, network elements and interface configuration parameters. To configure network elements, many parameters related to interfaces, ATMs, IP, and etc. and are needed. So every base station in 3G networks require a unit that handle ATM's connection. And also in this unit can be integrated with the base station or standalone, but requires parameter planning. And interface unit parameters related to hardware and PDH SDH interface unit for transmitting ATMs. And PDH SDH interface parameters configure a PDH SDH terminal and include testing parameter. For ATM termination or cross connection, parameters are the largest group and configure virtual channels, path, and their connections following ATM forum or ITU recommendation. And for IP addressing parameters, define a private and public IP addresses and routing table. And lastly, synchronization parameter define clock source and priority for ATM cross connections.
Greeting teacher, my name is Lee Hieng and I'll be responsible for the next points, which is about the ATM planning. So to make sure that 3G networks work properly, we need to plan and optimize them carefully. One important part of this is the ATM planning. So ATM is a technology that used to carry information through the network. When we do ATM planning, we need to think about things like what type of information will be carried, how different parts of the network will be connected, and also how many connections that we need. We also need to think about the physical details of the connections, like how fast they will be and how they will be set up. All of these things can be very complicated, especially when we have a big network. That is why we use special tools to help us with ATM planning. These tools can make the process even more easier and faster, so we can get the network up and running as soon as possible. And for this point 6.5, it will be about the synchronization plan. When we set up a 3G network, we need to make sure that all the different parts of the network are synchronized. This means that they all have the same time so that they can work together properly. To do this, we use a clock that sends a signal from the main control center to the other parts of the network. And of course, in 3G networks, we also use the same basic method that we did in 2G networks. We start with a clock at the main control center, which sends a signal to the base stations and other network elements. However, we also need to be careful if any parts of the network still use the old 2G technology. These parts are used to working with different kinds of signals, so we need to adjust the parameters carefully to make sure everything will work together smoothly. So this is the figure that illustrates the synchronization hierarchy in 3G transmission networks. So the detail or the meaning of this figure is that the synchronization hierarchy in 3G transmission networks, it's referred to the levels of synchronization that must be maintained among different network elements to ensure proper functioning. And at the top of the hierarchy is the clock, which will provide a timing reference for the entire network, and the mobile switching center, which is SC, and a media gateway, which is GW, and a radio network controller or NC, and a base station BS, all receive timing signals from the clock to ensure that they are synchronized with each other. And within the OR and C, the synchronization is maintained among different components, including the base station controller and also the node B, which control the base station. And the base station control also ensures synchronization among multiple base stations connected to it. And the goal of the synchronization hierarchy is that to ensure that all network elements are operating in synchronized with each other to maintain high quality service for user. And moving on to the last point in the point of number 6 is a network management plan. So when we design the transmission network for a 3G network, of course, we need to make a plan for how we'll manage the communication between the different parts of the network. And this plan will also include some information about how will we use the internet protocol layer to manage the data communication network, which is the layer above the ATM layer. And when we plan the data communication network, DCN, we have to think about the capacity of the interface that connect to the base station to the rest of the network. And this interface can handle between 32 and 128 kilobytes per second of data. And we also use IP over ATM or pure IP for the connections. In some case, we need to make sure that the IP addressing system we use can be expanded in the future, so that we need to add more elements to the network or upgrade the technology. However, we need to consider the equipment limitations when we plan the IP addressing. And for point 7, which is about the Ethernet radio, more than 60% of the world traffic is transmitted using microwave. And in the past, 2G and 3G networks were based on TDM technology. But consumer needs have changed, and also new technology has emerged. So Ethernet is a popular standard used in offices and also everyday life because it can handle high bandwidth and multimedia, that making it less costly, flexible, and easy to use. Microwave technology is a good fit for Ethernet because it can handle high capacities and mitigate the challenge that posed by fiber and also other cable systems. And microwave technology can perform 3 functions, which are aggregation, network, and transmission. And hybrid microwave is used for GSM, which stands for Global System for Mobile Communications, or GPRS, which is General Packet Radio Service, and also LTE, which is mean long-term evolution networks. And microwave technology is evolving every day and cost-effective as well. So these are some benefits of the Ethernet radio, meaning it's improved network performance and capacity. It's also faster and more efficient data transfer. And the last one is cost-effective and easier to use. And for point number 8 is about the 3G WCDMA, which is wideband code division multiple access transmission network optimization. So in point 8.1, it will be covered about the basic of transmission network optimization in 3G networks. So the optimization is done in 3G networks to improve network capacity and also the quality while maintaining the desired quality of service for mobile applications. And to improve 3G performance, transmission network optimization is necessary. In GSM networks, there are very few key performance indicators related to the quality of microwave network. However, in 3G networks, as the ATM is used, the number of parameters and the key performance indicator increase significantly. And data collection involves collecting existing data, network data such as site configuration, network topology, link budget calculations, commissioning data, and monitor data, and the performance of key performance indicator KPI. And most of the data collected is similar to the types of data collected in GSM. It's the global system for mobile communication networks. And this is the process definitions of the process definition. And the 3G networks optimize network capacity and quality with desired qualities of service for mobile apps and so on. And we have these figures which illustrates about the process of optimizing a 3G transmission network that can be broken down into the three main stages, which are the process definition, the network analysis, and also the master plan. So in process definition, the objective of the optimization are defined. These include determining the key performance indicator that will be used to measure the performance of the network, as well as identifying the tools and techniques that will be used to carry out the optimization process. And then the second stage is the network analysis, meaning that it involves analyzing the network to identify areas that require optimizations, and these include collecting data on network performance, capacity, and parameter settings. And the last one, which is about the master plan. So, based on the results of the network analysis, a master plan is developed that outlines the specific actions that will be taken to optimize the network. These include fine-tuning parameters, balancing radio and also the ATM or transmission network parameters, and last but not least is making changes to network topology and hardware configuration. And the master plan is then executed, and the network is continuously monitored to ensure that it is performing optimally. And for point 8.3, which is about the network analysis, in 3G network planning and optimization, we need to analyze the network in two ways. First, we need to analyze the capacity of the network to see how much traffic it can handle without any problems. And the second way is we need to analyze the quality of the network to make sure that the network is providing a good user experience for customers. And by analyzing the network capacity and also the quality, we can make sure that the network is running smoothly and it will provide the best possible experience for customers. And for the capacity analysis and also the quality optimization, so the GSM, the global system for mobile communication capacity, is calculating network capacity. It's easy. We can calculate the needed capacity of the link by knowing the site configuration. However, in 3G networks, capacity analysis is more complicated. We must consider traffic types and also the quality requirements to determine the capacity needed. And in 3G networks, an increase in traffic can lead to an increase in the number of signal processors or application managers. And to handle growth, the 3G networks add signal processor, the transceiver, base stations, and RNC, which is the radio network controller. And for the quality optimization, ATM is a type of technology that we use for high-speed communication that will guarantee the quality of service for certain applications. And in 3G networks, the use of ATM technology increased the number of things that need to be monitored and optimized to ensure high-quality service. And the two main areas that need to be focused on for quality optimization in 3G networks are the ATM technology and the physical layer. And for the analysis of the ATM layer, for good service in 3G networks, we need to check the performance of two types of ATM layers, which are the AAL2 and AAL5. And the AAL2 will carry circuit switch data, while the AAL5 will be carry the packet switch data. And we can use counters and performance indicator or managing system to check their performance. And delays can happen when network is busy or nodes are far apart or equipment doesn't work properly. So we need to keep an eye on these things and fix them to keep service quality high. And for the propagation, 3G networks delays can be caused by physical media and signal path changes. And the microwave link's performance is affected by weather or degrading ATM quality. And the ESR, which is the event-specific report, and SESR, which is the server event-specific record, degradation impacts the ATM layer performance. And it's essential to monitor the physical media and make it necessary improvement to provide the high quality service. And for the traffic, meaning that the ATM connections in 3G networks have specific parameters that they are designed for. So if the amount of traffic being transmitted through this connection goes beyond what was original planned, it will cause delay in the cell being transmitted. More than this, if there is an increase in traffic beyond what was expected, it may not be possible to maintain the same level of quality service that's initially granted. However, it's important to carefully plan and monitor network traffic to ensure that quality of service is maintained even during times of increased traffic. And the second last point for today's presentation will be about architecture. So when building a network, the switches and also other equipment that used can affect how well it performs. So to make sure that the network performs well, we need to consider three things, which are the CL or the cell loss ratio, CDT, which is cell transfer delay, and CDV, which is cell delay variation. And the CDVT, cell delay variation tolerance, is important because it sets the maximum time a cell can take to reach its destination. And if a cell takes too long, it will be discarded. And there are also standards for things like SESAMTM, which is statistical estimation for service availability in ATM networks, which will be measure the network's availability. And by paying attention to these things, of course, network planners can optimize the network's performance and minimize downtime. And this will be our last point for today's presentation, which is about the parameter setting in transmission 3G network planning and optimization. So planning and optimization a 3G network is harder than a 2G network. And there are three important things that we need to be considered, such as the dimensioning parameters, actual network data, and radio and also the ATM parameters. So dimensioning parameters are important, but they can change from when the network is planned to when it is launched. The actual network data is also important, like link capacities and power levels. The radio and ATM parameters will affect network performance, and making them better can improve the qualities of service. And the process will involve adjusting these parameters and balancing radio and also ATM or transmission network parameters. The optimized parameters are then checked to make sure that they are giving the desired performance. And these come to an end for our presentation today. So thank you, teacher, for listening to our presentation.